All right. This is the biggest TEDx I've ever spoken at. This is actually bigger than the real TED. So congratulations to all the organizers for making that happen. I'm very impressed indeed. I'm not really keen on aging. I'm not in favor of it. But unlike most of you, I'm really doing something about it. Where are my slides? Can I have my slides? Excellent. Great. Do I have a clicker?
Have a clicker.
Marvelous. This is what we like. So I'll explain what this means later on. This bit is about the sweet spot between prevention and treatment. We'll worry about that in a minute. But first of all, let me tell you one or two things about aging. First of all, it's fantastically expensive. This is just statistics from the USA, because it happens to be the statistics that I have the best information on. The red line shows how much bigger the US economy has grown over the past 50 years. The blue line shows how much bigger the expenditure in America on medical care has gone up. And it doesn't look too dramatic when you look at it like that. But if you divide one by the other, you get the green line. That shows you what proportion of the US economy is spent on medical care. It's gone up from like 5% in 1960 to something like 18%. That's how unbelievably expensive aging is. Good? Marvelous. So the first question we've got to ask is, how come? How come we're so hopeless at developing medicines that actually eliminate and alleviate and minimize the impact of the diseases of old age? I mean, we've done really, really well on the diseases that affect people irrespective of what age they are. You know, infectious diseases. 200 years ago, literally 40% of babies died before the age of 1. And I can tell you one thing, they didn't die of aging. They died of infectious diseases. And we got really good at stopping that from happening pretty much as soon as people figured out that hygiene was quite a good idea, and we started actually implementing it, and as prosperity increased, we were implementing it in a more and more widespread way. Of course, we started to actually develop vaccines and antibiotics and so on not long after that, and things got better. Why haven't we been able to get anywhere to speak of when it comes to the diseases of old age? Well, ultimately, here's why. Aging is a side effect of being alive in the first place. It is the lifelong accumulation of damage to the body. And that damage occurs as an intrinsic, unavoidable side effect of the way the body normally works. The body is set up to tolerate quite a lot of damage, but only quite a lot, not an infinite amount. And so eventually, the body gets to the point where it's got too much damage and things start to go downhill. That's all that aging is. It's a really, really simple concept. And when people tell you we don't know what aging is, they're talking nonsense. That we do know what aging is. That's all it is. So, now, what about the diseases of old age that are so expensive, as I told you a minute ago? Well, hello, they're parts of aging. How could a disease be a disease of old age? How could it be something that actually predominantly affects people who were born a long time ago? The answer is because it's some part of the later stages of this process that goes on throughout life. So it is simply having too much of the damage that being alive causes. That's all that age-related diseases are about. And what that means is it's no surprise whatsoever that we have made no real impact on those diseases despite the immense amount of effort that we have put into trying. These diseases are universal. You are going to get these diseases if you don't get the others. The only thing that stops you from getting cancer is dying of heart disease first, and vice versa. So we're not going to be able ever to cure these diseases in the strict sense, in the sense in which we can cure tuberculosis or something. When you cure an infectious disease, you do something once, and it eliminates it from the body, so that that person is never going to experience that disease again unless and until they are reinfected. Aging is not like that. Aging, being a side effect of being alive in the first place, we cannot eliminate it from the body in one-off treatments like that and make someone non-aging permanently. But that does not mean that these phenomena, these diseases of old age, are intrinsically resistant to medical intervention. They are amenable to medical intervention, it's just that it has to be a different type of intervention. So, first of all, let me just say one more thing about the economy. The bizarrely underappreciated truth that I just told you about is reflected in not only what we spend on medical care, but also in what we spend on medical research. And again, I'm giving you here statistics from the USA, but I can assure you that it's exactly the same here. It's exactly the same in any other country in the industrialized world. In the USA, there's an organization called the National Institutes of Health. It's part of the government, and it spends roughly $30 billion on medical research, on trying to develop treatments that work better against the diseases and disabilities that people suffer. Only 3% of that money goes to the institute, the component of the NIH called the National Institute on Aging, despite the fact that maybe 90% of medical expenditure goes on the diseases of old age. Now, what's going on there? Well, actually, there are other institutes dedicated to specific diseases, to cancer, to heart disease, to diabetes, and so on. And they're actually much bigger than the National Institute on Aging. But as I just explained, they're trying to attack these diseases in the wrong way. They're trying to attack them as if they could eliminate them from the body. It's actually even worse than that. Within the National Institute on Aging, only 1/6 of the budget is spent on actually trying to understand aging. That's the division of aging biology. The rest of it is spent on things like improving the dignity of the elderly and making sure that, local councils build ramps on curbs and stuff. And even within the division of aging biology, literally, certainly less than 10%, probably more like 2%, is spent on actually doing anything about aging, trying to develop therapies or knowledge that will lead towards therapies, as opposed to knowledge that simply tries to understand aging as a phenomenon. So it's unbelievable how little money is spent. Self Research Foundation, the organization that's been created around my work, is a charity based in California, and we've only existed for 4 years, and we're already not much smaller than the amount of money that the government of the USA is spending on this. That's absolutely scandalous. And it's scandalous because of this misapprehension of what aging is and how we might actually go about dealing with it. So, how might we go about dealing with it? Let's talk about some actual facts. Now, what I've essentially told you so far is that all the effort, all the money, all the thinking that goes on in the vast majority of people's minds, including people who have deep pockets, in the USA and the UK and everywhere else, is over here. It's all about treating the pathologies of old age as if they were diseases like any other disease and trying to eliminate them from the body, bashing away at the symptoms and just kind of hoping for the best and putting one's head in the sand, to be perfectly honest, pretending that this might have some significant effect, despite the fact that it never has had, and because of the nature of diseases of old age, it never can have. There are some people out there who have known this for quite a long time. For maybe the past century, actually, there have been a few scientists out there who have actually faced up to the complete unrealistic nature of the geriatrics approach, and they've been looking at what I'm going to call the gerontology approach, which is essentially to say, well, okay, look, some animals live a lot longer than other animals. They age more slowly than other animals. Within a species, some humans seem to age more slowly than other humans. Maybe we can study that and find out a lot of detail about how that happens, and having done so, maybe we'll be able to turn that knowledge into some kind of therapy to slow down the aging of averagely aging humans. That would be wonderful. Bit of a problem. We haven't actually succeeded, and I'll tell you why in a second. Well, no, I'll tell you right now, in fact. The reason why is because what that would involve is messing around with this thing here. Metabolism is the word that biologists use when they want to say being alive. It's the normal operation of the human body. Everything that we have to do in our bodies from one moment to the next, from one day to the next, just to keep going. In order to make this approach work, to slow down the rate at which metabolism does itself damage, the body does itself damage, we are going to have to somehow tune this and rebuild the way that metabolism works. And that is incredibly hard. Biologists still understand the human body very poorly. And that means that trying to play with it and to thereby stop it from making this damage, or stop it from making it so quickly, is incredibly difficult to do without doing more harm than good by, in some way, unintended side effects of the modifications one made. And that's essentially why people who have been adopting this approach, gerontologists, over the past maybe century, and certainly over the past 30 or 40 years, have become extremely pessimistic about the prospects of ever developing medicines that can substantially postpone the disease and disability of old age. But there is, in fact, a third approach, which somehow was almost entirely overlooked until about 10 or 12 years ago when I started promoting it. And I'm going to call it the maintenance approach. And you'll see how intuitive the maintenance approach is in a moment. First, I'm just going to define it. The maintenance approach simply says, let's not try and slow down this process where metabolism creates damage, and let's also not try to combat this process where damage eventually leads to these pathologies, these diseases and disabilities. Instead, let's uncouple those two processes from each other. Let's separate them by periodically diving in, repairing this damage when it is still subpathogenic, when it is still at the level that is not actually causing pathologies because it is tolerated by the way the body is naturally set up. And I claim that that's a much, much more realistic, plausible, near-term option, an option that we have a respectable chance of implementing in the next few decades, at worst. Now, why is it so intuitive? Well, simply because the human body is a machine. The human body is a very, very complicated machine, but it's still a machine, and therefore it's reasonable that we could extend the healthy, fully functioning longevity of the human body by the same kind of approach that we already successfully use to extend the longevity of simple man-made machines. Here's one. This car is 100 years old or thereabouts. It was not designed to last 100 years. It was designed to last 10 or 15 years. The reason it's lasted longer is because the people who owned it have done a lot of maintenance on it. They have done a greater amount of maintenance than the law requires, more comprehensive maintenance, and it's worked. Sufficiently comprehensive maintenance on any machine has the capacity to keep it going just as well as when it was first created. And the approach that I'm telling you about today for combating aging is exactly the same. So what does it actually amount to? Well, in order to tell you that, I have to tell you a little bit more about what this damage is that the body does to itself as a side effect of its normal operation. And the big breakthrough that allowed this approach to actually be fleshed out and pursued in the lab over the past decade or more was to realize that even though there are many, many, many different types of damage at the molecular level and the cellular level, they can all be classified into a very manageable number of categories, just 7 major categories. Here's the list of categories, and I've only got a TED-length talk. I've only got 5.5 minutes left, so I'm only going to go through them very quickly. I'm just going to talk about this one first of all, because you've heard about it, cell loss. That's simply cells dying and not being automatically replaced by the division of other cells. The reason you've heard about that is because stem cell therapy, which I'm quite sure you all have heard of, is simply the way to repair that. It's the way to repair that damage. And this is the type of damage that occurs in aging, just as elsewhere. In Parkinson's disease, for example, cells in a particular part of the brain die, and they're not naturally replaced, and if they die too fast, you get Parkinson's disease. The way to fix that is stem cell therapy to replace the cells that die. And we can't quite do it yet. It's in clinical trials, early stage. Sometimes it works, sometimes it doesn't. When it does, it works spectacularly, and I am completely convinced that within not very long, we will have reliable cures for Parkinson's disease that consist of this maintenance approach. So as I say, I can't go through all the others right now, but I will talk a little bit about why I think this is an exhaustive classification. It's been the same list for about 30 years. Since well before I came along, all of these things have been studied by gerontologists. Furthermore, I've been actually challenging people to add to this list for at least a decade, and nobody has come up with any cogent reason to add anything to it. So it's looking pretty good right now. Let me say a little bit more about the relationship between damage and disease. Some of these relationships are a little complicated, so it's worth putting this into your head in a clear way. Sometimes the relationship is simple. So in the case of cancer, cancer comes down to exactly one of these 7 types of damage. Cells dividing when they're not supposed to. I'm calling them division obsessed. That's a nice one-to-one relationship. But it's not like that with heart disease, because lots of different things go wrong in the heart during aging. Sometimes it's loss of cells. That's when your heart stops just because the pacemaker cells that control the heartbeat are insufficiently numerous anymore. Sometimes it's atherosclerosis, which causes heart attacks or strokes, and that is the result of molecular garbage accumulating inside cells in the artery wall. Sometimes it's actually garbage accumulating between cells. That causes a very nasty phenomenon called senile cardiac amyloidosis, which kills very old people a lot, actually, people over 100. And finally, it's possible to get arteriosclerosis. That's hardening of the arteries, which causes hypertension and all the effects of that, and that's caused by changes to this thing called the extracellular matrix. So, a rather more complicated story, but it's still a very clear story. We can say in a pretty confident way how hearts go wrong in old age. It's the same with Alzheimer's. There are 3 types of damage that happen in Alzheimer's. Molecular garbage inside cells, again, called tangles. Outside cells, called plaques. Cells dying. So it's a clear kind of relationship. So now, the bottom line, what do we do about it? How do we actually implement the maintenance approach? There are 4 fundamental paradigms. They all begin with R. They are called replacement, removal, repair, and reinforcement. And they apply to these 7 categories in... I'm not going on too much. Hello, good. In these various ways. What that means in concrete terms is these things. I've told you about cell therapy already. Without going through all of these in too much detail, we've got particular ways to do all of these things. Sometimes replacement, sometimes simply elimination of the superfluous material, the garbage that's accumulated. Sometimes repair of the material. Very occasionally, in a couple of cases, reinforcement. That means making the cell robust so that the damage which would normally have caused the pathology no longer does so. I want to talk very briefly in my last minute and a half about one thing that we're doing in our lab, which involves the number 1 cause of death in the Western world, cardiovascular disease, causes heart attacks and strokes. It all begins with these things called foam cells, which are originally white blood cells. They become poisoned by toxins in the bloodstream. The main toxin that's responsible is known. It's called 7-ketocholesterol. That's this thing. And we found some bacteria that could eat it. We then found out how they eat it. We found out the enzymes that they use to break it down. And we found out how to modify those enzymes so that they can go into human cells, go to the right place in the cell that they're needed, which is called the lysosome, and actually do their job there. And it actually works. Cells are protected from this toxic substance. That's what these graphs are showing. So this is pretty good news. But as I've explained, the way to apply comprehensive maintenance to aging is a divide-and-conquer approach. It is not a magic bullet. It is not some single thing that we can do, let alone a single thing that we could do just once. So we're going to have to get used to the idea not only of preventative medicine, treating people who are not yet sick, but also actually doing a lot of different medicines to the same people at the same time. We are pursuing, as you can see here, a lot of different projects. We're trying to cover all the bases, but we've only got a few $1 million to spend, so it's not too good. Now, the biography of me in the program called me a maverick, and it used to be somewhat reasonable to call me a maverick, but it isn't reasonable anymore because this concept is getting a lot of support. We don't just have a foundation behind this, we have a large number of extremely prestigious luminary scientists who are advising us and who have very publicly aligned themselves with this concept. So this is an idea which is really getting traction now, and luckily actually getting experimental effort that's actually happening. But of course, there's still a great deal to do. A couple of months ago, I ran this conference, or we ran it in Cambridge, in which, again, we had a lot of very prestigious scientists involved. We have, if you want to know more about the organization, an annual report on our website, and so you can see what's going on. But the key thing I want to end with, since my time has run out, is I want you to understand that it's not just the scientists that are responsible for hastening the development of this work. Everyone can do something. You're not allowed to ask for money at TED, so this is me not asking for money. But I will say that even though we're a US charity, we do have a subsidiary that's a UK charity, just in case you wanted to know. So we've got, an educational arm. We've got, obviously, if any of you are biologists, choose a field that's relevant to this. And the key thing I said there at the bottom, everybody needs to engage in advocacy. If you don't want to get Alzheimer's disease, or cancer, or diabetes, or cardiovascular disease, and if you don't want your parents to get those things, then get out there and reduce the chances of their doing so by hastening this work, by getting people to understand that aging is potentially amenable to medical intervention in your lifetime. Thanks very much.